Good day everyone. Today we'll solve a problem on Fluid Mechanics Chapter 8 Open Channel. In this chapter, we will focus on the fluid flow that is mainly or only governed by the atmospheric pressure and the gravitational acceleration. So, the fluid flow in our system is only caused by the atmospheric pressure and the gravitational acceleration. That's the definition of an open channel. So in our problem, a trapezoidal canal has a dimension as shown in the figure. If the slope of the canal is 0.002 and the roughness coefficient is 0.02 and it is full of water, calculate the discharge of the water and use R or the radius, hydraulic radius 1 meter. So in our figure, we have 2 meters as the base. We have value this triangle here and the triangle here are just the same. So our x is equal to 1.5 and we also have an angle here of 40 degrees. So let's write all our givens. We have the base of 2 meters. We have x is equal to 1.5 meter. We have r of 1 meter. We have the value of the roughness coefficient of 0.02. We have the slope of 0.002. And to solve for the value of the discharge, because this is what we're looking for, discharge is equal to area times velocity. And to solve for the area of the trapezoid is equal to base times the d or the depth of the trapezoid plus the x times d. This triangle here and this triangle here are just the same, so if you add these two triangles it will result to a quadrilateral, which is base times height or x times d. And to solve for we don't have the value of d yet, but we can use the law of sine to solve for the d. If this is 40 degrees, therefore this angle here is 50 because this one here is 90, so 90 minus 40 is 50, and this one here is also 40. So using the law of sine 50 over 1.5 meter is equal to sine 40 over d. We only have one unknown here, so evaluating the equation to solve for d, we have the value of d 1.26 meters. And we can now substitute it to the value. We can now substitute its value to our equation. But we don't have the value of v yet. But v is equal to 1 over the roughness coefficient times r raised to the 2/3 times s raised to 1/2. And we have the value of n, we have the value of r, we have the value of s here. So substituting the values we have and then simplifying the equation, we have the value of v of 2.236 meter per second. And we can now plug this value in the equation we have to solve for the discharge. And simplifying the equation, we have the discharge is equal to 9.861 meter cube per second. And this is the final answer for our problem.